In previous sections of Chapter 2, we addressed multiplication of fractions. And now in section 2.7, we are moving on to division and applications of fractions. And so here we have 4 learning objectives to find, number 1, the reciprocal of a number, then how we divide and simplify fraction notation, and then how we use that to solve equations of the type ax equals b, or x times a equals b, where a and b may be fractions. And then we're going to look at some applied problems involving division of fractions. To lead into this discussion, we look at reciprocals first. And so here's the definition. If the product of 2 numbers is 1, we say they are reciprocals of each other. Instead of the word reciprocal, in some textbooks you will see multiplicative inverse. It's a bit longer expression, but it conveys the same meaning. And that is to find the reciprocal of a fraction, we simply interchange the numerator and the denominator. So in other words, for example, if the number is 3/4, then its reciprocal is 4/3. Because 3/4 times 4/3, 3/4 times 4/3 is equal to 1. The 3's cancel, the 4's cancel, so the whole expression equals 1. So that is the idea of reciprocal. So now we're going to look at some simple exercises. Exercise number 1 asks us to find the reciprocal of 2/5. So we exchange the denominator and the numerator. So that becomes 5 divided by 2. That's all there is to it. Okay, that's a reciprocal of 5/2 is the reciprocal of 2/5. The reciprocal of 10/7 would be 7 divided by 10. It's very simple. Now, number 3 seems a little different because here we look at 9. But we also remember that 9 can be written as 9 divided by 1. So now we've explicitly a denominator and a numerator. When we exchange them, then that's equal to 1/9. And similarly, number 4, the number is 1/5, so we exchange the numerator and the denominator, becomes 5 divided by 1, which of course is equal to 5. So here you have the explanation of what a reciprocal is and a few examples, what it actually looks like. Then there's a special number, and you can probably guess what that is, and that's the number 0. And that is that 0 does not have a reciprocal. And the reason why is that 0 divided by n, which is equal to 0, is because n divided by 0 is not defined. Remember, when 0 is in the denominator, this expression, this number is not defined. Now we're coming to the key of this section, and that's division of a fraction. So to divide fractions, multiply the dividend by the reciprocal of the divisor. Well, if this statement confuses you, it may be a sign that your math vocabulary hasn't really kept up with the demands of it. We talked about fractions, we talked about dividends, we talked about reciprocals, we talked about divisors. But when that all comes together in one sentence now, that might be confusing. So I will give an explanation, of course, but before I move on, I really want you to think about the sentence first and see if that makes sense to you. It really should, if you remember what a fraction is, what a dividend is, what a reciprocal is, and what a divisor is. Okay, so I won't keep that a secret. I'll get into it right now. But I would just, at this point, challenge you a little bit to think about the definitions of these words and see if you can remember the definitions. And if that's a bit of a problem, I would really suggest you beef up on learning your math vocabulary so that it is an active vocabulary that you can actually use it instead of having hopes that you might remember the meaning of the words. Again, it's really critical, and not just in this particular context, but just in general, what we're discussing here throughout all these different sections, that you really keep track of your math vocabulary. Otherwise, it'll get more and more difficult because we use more and more words, more and more terms, and the better you remember them, the better you will be able to work with the concepts and expand on them. So let's look at this. So when we have a fraction, 2/5 divided by 3/4, then we know that 2/5 is the dividend and 3/4 is the divisor. Okay, so this is a dividend, the first number here, that's a dividend. We had this before, so it's not new, dividend. And this is the divisor. So what the statement says, to divide fractions, multiply the dividend by the reciprocal of the divisor. So in other words, here's the dividend, as before, 2/5, but now we take the reciprocal of the divisor, and the reciprocal of 3/4 is 4/3. So 2/5 times 4/3. So in other words, now we are back to simply multiplying two fractions. We know how to do that. We take the product of the numerators and divide it by the product of the denominators. In this case, it's 8/15. 2 times 4 is 8, and 5 times 3 is 15. The only thing to check in general is, can this fraction be reduced? In this case, it cannot be reduced, so that's the final answer then. Again, make sure you have clarity about the sentence and have maybe a little go-to example in your mind, how that actually looks when we divide a fraction by a fraction. Okay? So having understanding and clarity, that is critically important. So we look at some exercises here, and we look at number 5, a guided solution. So here we are dividing 6/7 by 3/4. So again, this is the dividend, and this is the second expression is the divisor. I'm just going to write it here. Okay, so what the division tells you to do is we leave the dividend alone, but we take the reciprocal of the divisor, and the reciprocal of 3/4 is 4/3. Okay. So then now we have 6 times 4 divided by 7 times 3. And we look at the prime factorization of 6, that's 2 times 3. And the prime factorization of 4 is 2 times 2. And so we realize that we have one factor of 3 in the denominator. So we can write that with the other 3 in the numerator as 3 divided by 3 times 2 times 2 times 2 divided by 7. And since 3 divided by 3 is 1, we just multiply the fraction by 1. In other words, we get the same number back, which is 2 times 2 times 2 divided by 7. And since 2 times 2 times 2 is 8, the final answer is 8/7. Okay, so this is a very simple example, and I can only recommend that grab a piece of paper and maybe do it yourself and see if you can develop in the same or close to this way, so that you have clarity about every step that you're taking. So how we get to the final answer, that would be really important. So the next example is number 6, 2/3 divided by 1/4. 2/3 divided by 1/4. So that means we multiply 2/3 by the reciprocal of 1/4, which is 4 divided by 1. And so that means 2 times 4 divided by 3 times 1, or simply 8 divided by 3. 2 times 4 is 8, and 3 times 1 is 3. So that's the answer for number 6. 8/3, or 8 divided by 3. Similarly, when we have number 7, so number 7, we have 4/5 divided by 8. Of course, that can be written as 4/5 divided by 8 divided by 1 to fit the pattern of a reciprocal. So in other words, we multiply 4/5, the dividend, by the reciprocal of the divisor times 1 divided by 8. And so that is equal to 4 times 1 divided by 5 times 8. And as we develop the prime factorization of the numerator and denominator, we get 2 times 2 times 1 divided by 2 times 2 times 2, the prime factorization of 8, times the 5. And that's equal to 2 divided by 2 times 2 divided by 2, that takes care of this, times 1 divided by 2 times 5. And since this is equal to 1 times 1, then the final answer is 1 divided by 2 times 5, which is equal to 1/10. So this then is the answer to number 7, 1/10. Similarly, we do number 8. So 60 divided by 3/5, we write as 60 divided by 1 divided by 3/5. In other words, that's equal to 60 divided by 1 times 5 divided by 3. Then we do the prime factorization of 60. So it's equal to prime factorization of 60 is 2 times 2 times 3 times 5 times 5. So that's the prime factorization of 60 times this 5 here, divided by 1 times 3, which we can then write as 3 divided by 3 times 2 times 2 times 5 times 5 divided by 1. And since 3 divided by 3 is 1, we only have 2 times 2 times 5 times 5, and that's 4 times 25, and that's equal to 100. 100 divided by 1 is equal to 100. So therefore the answer for question number 8 is 100. In number 9, we are asked to divide this expression by multiplying by 1. And so multiplying by 1 would be by the reciprocal of 6/7. So here's how it works. So that's equal to 4/5 divided by 6/7 times 1. And for 1, we just make a fraction. 4/5 divided by 6/7. And now we use the reciprocal of the denominator, of the divisor. So there would be 7/6 divided by 7/6. So what's happening now in the numerator, we have 4/5 times 7/6. In the denominator, we have 6/7 times 7/6. And so here we're multiplying a number times its reciprocal, so we know that the denominator is equal to 1. And so in the numerator, we can now use the prime factorization. And so the prime factorization of 4, of course, is 2 times 2, and then times 7, divided by 5, times 2 times 3. 2 times 3 is the prime factorization of 6. All divided by 1. So we can leave out the 1 now, and we just look at this part here. So we're looking at 2 times 2 times 7 divided by 2 times 3 times 5, just rearranging the factors in the denominator. So we have 2 divided by 2 times 2 times 7 divided by 3 times 5. That's equal to 1. So therefore we only have 2 times 4, which is 14, and 3 times 5 is 15. So 14/15 is the result, or it's the quotient of these two fractions. We're going to write the answer to the left of it so you know what it refers to. 14 divided by 15. That's the answer to this big fraction here. Little different approach, but it works. So what else could we have done? Well, if we look at this fraction here, let me just redo it in a different way. 4/5 divided by 6/7. We could have written that as 4/5 divided by 6/7. And then just use the usual approach as 4/5 times the reciprocal of 6/7 is 7 divided by 6. And again, we do the prime factorization, 2 times 2 times 7 divided by 2 times 3, the factorization of 6 times 5. And you can see it'll give us the same answer since the 2's cancel, or we make it equal to 1 as a factor, so it's equal to 14/15. So sometimes, well, there usually is more than one way to get to the correct answer. So here's the alternative way of solving that particular problem. Next, we'll be looking at equations and how to solve them. So let's look at equations as a form a times x equals b, and x times a equals b, where a and b may be fractions. And what we are going to do, we proceed exactly as we did with equations involving whole numbers. In other words, when a and b and x in most cases were whole numbers also. And that was simply this. We divide by a on both sides. Because if we divide by a, that isolates x. Okay, so we do the same thing. So as an example, we look at this statement here. N times 3/4 equals 24. So in this case, a is equal to 3/4, so we need to divide by 3/4 on both sides. So let me just do it here. So we have n times n divided by 1 times 3/4. So we divide the whole left side by 3/4. And of course we divide the right side 24 by 3/4 also. So that means then on the left side, since the 3/4 cancel, we have n. We've isolated n. Since the 3/4 cancel. And on the right side, we have 24 divided by 3/4. So we can write that as 24 divided by 1 divided by 3/4. So that is then 24 divided by 1 times 4 divided by 3. And when we look at the prime factorization of the numbers, we have 24 is equal to 2 times 2 times 2 times 3 times 4, which is 2 times 2. And in the denominator, we have 1 times 3. So the 3's cancel. And we have only 2 times 2 times 2 times 2 times 2. So we're going to cancel the 3's. And so we only have 2 times 2 times 2 times 2 times 2, and that's equal to 32. So n equals 32 in this problem statement here. 32 is the answer. The next exercise, number 10, is very similar. 5 6 times y equals 2/3. And since y is multiplied by 5 6, we divide both sides by 5 divided by 6. 5 divided by 6. So that means we've isolated y. So y is 2/3 divided by 5 6, which means 2/3 times the reciprocal of 5 6, which is 6 divided by 5. Then the prime factorization here is 2. That's this 2 here. And the prime factorization of 6 is 2 times 3. In the denominator we have 3 times 5. So now we can write this 3 divided by 3. And then in the numerator we have 2 times 2 divided by 5. And since 3 divided by 3 is 1, so we multiply the whole fraction by 1, which gives us this fraction here. And since 2 times 2 is 4, the correct answer is 4 divided by 5. Again, I would urge you to do your own calculations on a piece of paper, just to see you understand every step along the way here that we took to arrive at the correct answer. And as I suggested before, just to look at some examples I do for you here may not be enough. And so again, I highly recommend that you do additional drill exercises on pages 135 for this particular section and 136. And then application problems, we do a few more here in just a moment. But on pages 136 and 137 are application problems. You can also do to learn more and understand better what you're doing here with fractions. Let's look at an application problem number 12. Each loop in a spring uses 21 divided by 8 inches of wire, 21 eighths. How many loops can be made from 210 inches of wire? So then number 1, let's familiarize ourselves with the problem. Familiarize. So for example, you could say that n is the number of loops. So n is the number of loops that can be made from 210 inches of wire. Number 2 would be to translate this into a mathematical statement. So in other words, 21 eighths of an inch, or inches rather, that's per loop, times the number of loops has to equal 210 inches, the length of the wire. Okay, number 3 would be the actual calculation, or the solution rather, to this problem. So we solve that. So in other words, that looks like 21 eighths times n equals 210. Now we divide both sides of the equation by 21 eighths. So 21 eighths divided by 21 eighths. Times n equals 210 divided by 21 eighths. So this on the left side now we've isolated n, and on the right side we have 210 divided by 21 eighths. We multiply by 8 divided by 210, by 21 rather. So we can write 210 as 21 times 10 times 8 divided by 21 times 1. And 21 divided by 21 is 1. So that means n equals 10 times 8, or 80 loops. Remember, 21 divided by 21 is equal to 1, and multiplying by 1 gives us the same number. And the number divided by 1 is that number itself. So 10 times 8 is 80 loops. Number 4, we check our calculations. Check. And that is 21/8 times 80. Is that equal to 210? And we check that, and that's correct. And now number 5, we state our answer by saying 80 loops. State our answer: 80 loops can be made from 210 inches of wire using 21/8 inches per loop. Let's look at number 15. And number 15 is a question. Someone goes on a trip. John Penner sells soybean seeds to seed companies. After he'd driven 210 miles, 5/6 of a sales trip was completed. How long was a sales trip? Okay, let's get some clarity here and to familiarize ourselves with the problem. And so the first thing we're going to do is we're going to say, okay, so let M, familiarize, let M be the miles, or the length of his total trip. Length of the total trip. In miles. So that helps. Now let's think about it. We said that when he's driven 210 miles, that is 5/6 of a sales trip. So, and again, of means multiplication, right? So when we now translate this here, so we think of it this way: 5/6 of a sales trip. And again, the length of his trip is M, 5/6 of his trip, sales trip, is equal to 210 miles. Again, of means multiplication. So then in the we solve this by replacing the sales trip with the letter M, the length of the trip. So in other words, this now becomes 5/6 of, or multiplying by M, and that's equal to 210 miles. And of course, the way we solve that particular problem is we divide both sides by 5/6. So 5/6 divided by 5/6 times m equals 210 divided by 5/6. So now we've isolated m on the left side because the 5/6 cancels against the 5/6. So m was equal to 1 is equal to 210. And now we multiply by the reciprocal of 5/6, which is 6/5. So the prime factorization of 210 is 2 times 3 times 5 times 7 times 6. The prime factorization of 6 is 2 times 3. So we notice we have a 5 in the numerator and the 5 in the denominator, so we can cancel them. And so we have left 2 times 2 times 3 times 3 times 7, and that is equal to 252. And that would be miles. So that's what m is equal to. So number 4, we check the answer, and we ask ourselves, is 5/6 times 252 equal to 210? And first of all, it makes sense, because if we multiply 252 by a number less than 1, the result will be less than 252. So that is equal to 210. So that checks. And then number 5, we state the answer, that the length of the total trip is 210 miles. Is 252 miles. The length of the total trip So that was the length of the total trip, 252 miles. Again, I recommend that you take a piece of paper and a pencil and work this out on your own. Now that you know the answer, you can always go back to the in-between steps if that is important, but you can probably figure it out on your own. And that's really what it takes. So word problems, that's what we've been dealing with here, are by nature a little more complicated than simply solving some equation. The equation solving part is usually the easiest part of all when we come to these steps. The more difficult part really is to have clarity about what the problem is, to figure out what's really the question, and then to break it down into these 5 steps: familiarization, the translation and solving of the problem. Checking the answer is usually not a big problem either, but it's a good idea to do that. And then to state the answer as a sentence, that's always a good idea. Again, that you have clarity what that number even represents that you came up with. So again, the unit of measure, in this case miles, would really be important to include that. The answer is not 252, it's 252 miles. Okay. So again, I wish you success with doing some more of these application problems from the book. And word problems, that's really what the real world consists of. Very seldom do you have to solve an equation. It usually comes from in some context, and that is why it's a real good idea to develop the ability to solve word problems. So clarity, translation, solving the problem mathematically, checking the answer, and then stating your answer. Those 5 steps, that just has to be almost like a reflex to solving problems. This concludes section 2.7, and this is also the conclusion of chapter 2.